Hello all, I am Dr. Pravas. In today's class, we'll discuss about associativity and precedence of the operator. Okay, so see, first we'll discuss about the associativity. First we'll discuss about the associativity. So what is the meaning of associativity? Just see the definition. If a grammar, if a grammar is if a grammar is left recursive, if a grammar, or we can say production, if a grammar or production, we can say it is production, it is also, if a grammar or production is left recursive, then its corresponding operator is left recursive, for example, say, for example, suppose e2 here, e2 e plus t, okay. Just say this production, the given production of the given grammar is left recursive. This given grammar is the given production is left recursive because in the left part it is e, and in the leftmost non-terminal in the RHS part is also e. Means both are same. So that's why it is called as left recursive grammar. This is called left recursive production. Since this given grammar is left recursive, so the corresponding operator is here plus, the corresponding operator is here plus, the corresponding operator is left associative. Means here plus, the associativity of plus symbol, the associativity of this given means plus symbol is always left associative. And the next point, it moves from left to right. Since it is left to, since the operator plus, since the operator plus is left associative, so the operator plus generally moves from left to right, How it moves from left to right, we'll discuss later with the help of example, right? Next point, if the grammar or production, we can say, if the grammar of the production is right recursive, if the grammar or any production is right recursive means, suppose like this, e2 t star e, right? So this grammar is right recursive because in the left part it is e, and the rightmost non-terminal is e. So the given grammar is called as what? Right recursive. If a grammar is called as right recursive, or production is right recursive, then its corresponding operator is star. Then its corresponding operator is called as what? Right associative. So the star operator is always what? Here the star operator here, in this case, if the grammar is right recursive, so the star operator is right associative. This is called as the right associative, and it moves from what? Right to left, If the operator is left associative, it moves from left to right. If the operator is right associative, it moves from right to left. It is very simple. Okay, so later we'll discuss about the example. What is the example of associativity? Okay, now we'll discuss about the precedence of the operator. Just say, so what is the meaning of precedence? If the operator is evaluated at bottom level, then the precedence of the operator is high. If the operator is evaluated at top level, then the precedence of the operator is low. Okay, then the precedence of the operator is low. For example, say E star t T plus F L. So here, if the what is the just see the definition. If the operator is evaluated, at bottom level, then the precedence of the operator is high. That means here plus operator and star operator. There are two operators, plus and star. So which precedence is high? Since plus is evaluated at the bottom level, so the precedence is high. The precedence of plus is high as compared to the precedence of star, because star is evaluated at top level. Star is evaluated at top level and plus is evaluated at bottom level. So if the operator is evaluated at bottom level, then the precedence of the operator is very high. If the operator is evaluated at a top level, then the precedence of the operator is very low as compared to operator evaluation of operator at bottom level. Okay, now we'll discuss some examples that are related to associativity and precedence. Okay, let's see. Consider the following grammar. This is the grammar. Consider the following grammar. Find the associativity. Find the associativity of star and plus operator. Find the associativity of star and plus operator. Just see. Here S2, just we'll discuss the first prediction. Just see the first prediction. S2 T star P. S2 T star P. Here there is no recursive, means the first prediction is neither left recursive nor right recursive. So we cannot find out any associativity of star operator in the first prediction. Okay, now we'll see the second prediction. See here T2, just see here T and here T star U. Just see the third prediction. We'll not consider this prediction. We'll just consider the next third prediction. T2 what? T star means just again writing T2 T star U. So here T is left recursive. Here T is what? Left recursive. Since T is left recursive, so star is what? So star operator is left associative. Star operator is left associative. Now we'll see, now we'll find the plus operator. Now we'll find the associativity of plus operator. Just see this prediction. Here P and P. Here P is what? Right recursive. Since P is right recursive, so here plus. Here the plus operator plus is right associative. It's right associative. Okay, so find the associativity of star and plus operator. Star operator is left associative and plus operator is right associative. So since plus operator is left associative, so it moves from what? Left to right. Since plus operator is right associative, so it moves from what? Right to left. Okay, so now we'll see, now we'll discuss one more example based on here. Consider the following parse tree. Just see the parse tree. So here we'll find question is, I'm just adding here, just find the precedence. Find the precedence. Find the precedence of the given operator. Operators, right? So here there are two operators. Just see, here there are two operators. What? One is hash and one is dollar. There are two operators are given. So we'll first find the precedence of the given operator. Just say here dollar is evaluated. Here dollar is evaluated at what? Bottom level. Since dollar is evaluated at bottom level, so the precedence of dollar is high. Since hash is evaluated at top level. Since hash is evaluated at top level, so the precedence is here low. That means dollar precedence is high as compared to hash operator. One more question here. We just add how to evaluate this expression. How to evaluate this expression? Just see how to evaluate. This is very, very important. Here dollar means the operator dollar is the precedence of dollar is very high as compared to what? Hash. So first we'll evaluate dollar operator. That means either we'll evaluate this one. Sorry, either we'll evaluate this one or we'll evaluate this one. Means either we'll evaluate B to C or C to D. B to C or C to D. Okay. Just see. First we'll evaluate. Just see the tree. First, how to evaluate? Just see. First we'll evaluate what? BC means this one. First we'll evaluate this part, means B to C, because just see the tree. First we'll evaluate this part. First we'll evaluate B to C. Then let it is X. Then we'll evaluate what? This part. Let it is Y. That means we'll evaluate this part. Okay. Then we'll evaluate what? This one. E to F. Then we'll evaluate E to F. Let it is Z. Okay. Then we'll evaluate this part. What? Y, Z means this part. Let it is B. Okay. So we can write like this. I'm just using some other color. Okay. Then we'll evaluate the whole part like this. Okay. So here we can also find out. What? We can also find out the associativity. Find the precedence of the given operator, and also we can find associativity. So here dollar. There are two operators, hash and dollar. Just say dollar moves from what? Left to right. Dollar moves from, first we'll evaluate B to C. Just say first we'll evaluate B to C. Then we'll evaluate what? This part with, then we'll evaluate this part. So dollar moves from what? Where? Moves from left to right. So dollar moves means we'll first evaluate this one, then we'll evaluate this part. So that's why what? Dollar moves from left to right. Since it moves from left to right, dollar moves from left to right, so the associativity of dollar is what? Left associative. Similarly, we can see the associativity of what? Hash. First we'll evaluate this part. Then we'll evaluate this part. Means first we'll evaluate this part. Let it is 1, 2. First we'll evaluate this part. Let it is 3. Just say first will means this part means what? Z part. Then we'll evaluate B part, means this part, the whole part. That means it moves from first we'll evaluate this search, then we'll evaluate this search. That means it moves from right to left, right to left. Right to left means if any operator moves from right to left, the associativity, the corresponding associativity is right associative. Okay, simply just see the tree. First we'll evaluate this separator, then we'll evaluate this separator. Means first we'll evaluate this separator, means it moves from left to right. See here, just see the hash operator, it moves from right to left, right to left. You can also just see the operator, then we can identify it means where to move, means where it moves from left to right or right to left. Okay, we can easily identify. Okay, now we'll see one more example. Let's see. Consider the binary operators. There are two operators. Consider the binary operators. One is upper arrow mark, one is lower arrow mark. Upper arrow mark, one is lower arrow mark. Consider the binary operators of upper arrow mark and lower arrow mark with the precedence of operators. With the precedence of operators, lower arrow mark being lower than the upper. That means lower, see, the precedence of lower is always low as compared to upper arrow mark. The lower arrow mark being lower than the operator means upper arrow mark. Operator of upper arrow mark, this one, operator upper arrow mark is right associative. Right associative means it moves from right to left. Then lower arrow mark and operator lower arrow mark is left associative. Left associative. Left associative means it moves from left to right. It moves from left to right. Generate the parse tree for the, this is the given expression. This is the given expression. So we'll find out the parse tree. We'll find out the parse tree. Let's see how to find. See, everything is given. Everything is given. Since upper arrow mark its precedence of upper arrow mark is higher and the precedence of lower arrow mark is low. So the low arrow mark, sorry, the lower arrow mark will, the lower arrow mark means will evaluated on the top level. That means top level and upper, and the upper arrow mark means this arrow mark. Upper arrow mark will evaluated at bottom of level. So say first we'll evaluate either this one or this one. Either we'll evaluate either this one or this one. How to evaluate? So just say since the upper arrow mark is right associative. Right associative means it moves from right to left. That means first we'll evaluate this one, means 4 to 3. 4 upper arrow mark 3. Just say this is 4, this is 3, this is 4 and this is 3, right? Then we'll evaluate this part because it moves from right to left. It moves from where? Right to left. So first we'll evaluate this one, then we'll evaluate this part, right to left. So this is 3. Okay, we can also write like this. We can use bracket. First we'll evaluate this part, then we'll evaluate this part. So we just connect simply. We just simply connect. Then So since it is lower arrow mark is left associative, lower arrow mark is left associative. So by default, we will evaluate this one, the first, this one is the first. So this is 7. So we'll evaluate this one, right? Then we'll evaluate this one. Okay. So this is the generated pass tree from the given expression. Okay. So these are the similar examples. These are some examples that are related to associativity and precedence. Okay. In future, we'll see some means get examples. Okay. In the next class, we'll discuss about removal of ambiguity or conversion from ambiguous grammar to unambiguous grammar. Okay. Thanks for watching.